Alright guys, so now we're going to start taking a bunch of our information that we know and start to look at if I have multiple monomials that are factors of a larger polynomial and seeing what we can decipher from that first. Eventually we're going to get to multiplying these out and then you'll be able to factor them, but let's just talk about why we want to factor them and what information that gives us. So for instance, if we just have x minus 2. It's just a simple factor. Obviously, that's a factor of itself. It's no big deal. But what can we tell from this? Well, what we do know is that what happens when x is equal to 0? Well, when x is 0, then we know that that is negative 2. So we know that y is equal to negative 2. And what is that? That is going to be our y-intercept, right? So when x is 0, our y is negative 2. And if we do the opposite, let's say we do, what happens when y is 0? Well, x minus 2 is equal to 0. We add 2 to both sides, and we know that x is equal to 2. So x is equal to 2. So we have two coordinates. We have a 0, negative 2, and we have a 2, 0. Now, in this case, we can just plot that. It's a straight line, so it's really not that big of a deal. But that's how we get our x-intercept. Now, I want you to see that we've talked about what a constant is. And a constant is this number right here. It does not have an x attached to it. It's just a number by itself. And if we haven't connected this yet, our constant is how we get our y-intercept without doing a bunch of extra math. But let's see what else can we learn if we have multiple factors. So let's have multiple factors. Let's do, we know what x minus 2 is. We're going to keep that. And then let's do x plus 5. What is this? So again, let's test this out. So we're going to do what happens when y is 0. What happens when x is 0. Okay, is this an even or odd? Is this a positive or negative? And that should be enough for us. Yeah. So when x is 0, that's actually probably the easiest one to do, right? So 0 minus 2, and then 0 plus 5, right? It's a negative 2 times a 5, and that gives us negative 10. So that means that when x is 0, y is a negative 10. Okay, now that's important to see that. Now I'm going to show you a really easy way to get that without putting the 0 in. We'll look at that in a minute. Now let's just talk about even and odd. So we talked about our end behavior. To know what our end behavior is going to be is that two questions. Is it even or an odd function, and is it a positive or a negative? Well, this is pretty easy to think about. Even or odd. How many x's do we have? That's when we always talk about if it's x to the third power, that means we have 3 x's. If it's x to the fifth power, we have 5x. We have x to the eighth, we have 8 x's. How many x's do we have here? We have 2, right? We have, get my red marker out here. We have 1, 2. So that means it's even. Now let's look at this. What is our coefficient of this one? This one's a positive 1, and this one's a positive 1. So a positive times a positive. And you can even write it positive times a positive. Positive times a positive is a positive. Okay, so we know it's even, which means it's the arrows are going the same way, and it's positive, so we know that they're both going up and up. Those should be fairly simple to see. We've done some of those already. Now, let's talk about our y. If you watched the previous warm-up video, we're going to try to figure out when these are equal to 0. And again, we state, if this is 0, 0 times whatever number this is, doesn't matter what it is, it's still 0. And the same thing as this is 0, this whole thing right here, if that's 0, doesn't matter what number that is, that's still 0. So we're saying when x minus 2 is equal to 0, it doesn't matter what that is, it's the whole thing is 0. And the same thing with x plus 5. And then we just solve for x. So in this case, what do we do? We add 2 to both sides, and that gives us x is equal to 2. We subtract 5 from both sides, and x is equal to a negative 5. So we just proved that when x is 2, y is 0, and when x is negative 5, y is 0. Alright, so now we have our x-intercepts, our y-intercepts, the direction of what we're doing. Now, I'm just going to show you a shortcut real quick on finding the y-intercept. If I were to multiply every constant, so remember, it can only be the constant, because our constant is that it cannot have an x attached to it. If I were to multiply each constant in any of the factors, so if I had like 15 of them, and I had negative 2, negative 3, 5, 6, whatever. I can multiply them all together. And if you look at this, what is negative 2 times 5? Well, that's negative 10. So we could have figured that out quickly. I'm going to do that next time to show you how it works. So now we're going to graph this. Okay, so we know it's up, up. This is what I would do, guys. I would go up, up. I do that first. And then I'm going to plot all my points. So let's do 2, which is right here. 5 right there. And we got to do this one. Now, I did a bad job. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There I am. So again, all we can tell, all we know right now is that it goes something like this. Okay? We're doing a rough sketch. Now, realistically, if we've done these enough, we should know that our minimum is in the middle. So we have 1, 2, 3, 4, 5, 6, 7. So we should have like 1, 2, 3 in our minimums right here, but that's neither here nor there. We really haven't talked about that yet. But just know that's how it works in the parabola. Okay, I'm going to do one more really quick and see if you can get the answer right along with me. No, I don't want to do 3 again. I want 3 separate answers. Oh, let's just do plus 2. I know I used it last time. I don't know why I like plus 2, but I do. All right. So let's do x-intercept or y-intercept. So even or odd, plus or negative, and then we're going to graph it. Okay, our x-intercept. Our x-intercept is when y is 0. So again, what can we put into x to make x plus 3 equal to 0? That's what we're looking for. Same thing here. Same thing here. Now, hopefully, I'm not going to go too fast for you guys, but you subtract 3 from both sides, and that gives us when x is negative 3, y is 0. When x is 1, y is 0. And when x is a negative 2, y is 0. Remember, all I'm doing is I'm put negative 2 into x, right? So if this right here is 0, it doesn't matter what this is, because 0 times that number is going to be 0, and 0 times that number is going to be 0. It does not matter. Okay, now, when x is 0, what is y? So we're going to use my rule. We're just going to multiply all the constants. 3 times negative 1 is negative 3. Negative 3 times 2 is negative 6. And really, guys, if you just think about it, we put 0 into here, what are you left with? 3. Put 0 into here, what are you left with? Negative 1. 0 into that right here, you're left with 2. You can just multiply them all together. Okay, how many x's do we have? We have 1, 2, 3. So we have an odd number. This is positive or negative. They're all positive x's. There's no negative there, so it's a positive. So what do we know? By our end behavior, we know it's down here and up here. All right, let's graph this. 0, negative 6. So 1, 2, 3, 4, 5, 6. Okay, so let's graph these. 1, 2, 3. So it's right there, right there. Boy, I made these really tight. Okay. That's right. So all we know is that they have to go through all these lines. Now, something else that we need to make sure we understand is that if it starts down here and it goes through 3 times, there has to be at least 2 turning points to make this work. And our turning points is always always our degree minus 1. Well, what is our degree? We already said it was 3, so it's 3 minus 1, which gives us 2. All right, but let's do this. So we're going to go up 1, 2, 3. It's a sketch. It's a rough sketch. All we know is that on the x-axis, it intersects it these 3 times. Our y-axis, we know it intersects that. We know it starts down here, it ends up there. That's all we know, and so we can do as many times as we want to.